Hi, this is Ryan from AIS, and in this video I'd like to show how to build Bareflank and run it using EFI. To get started, the first thing we're going to need is a working directory. Now, working directories are more completely explained in the video that we have on our front page for GitHub. For this specific example, we're going to need a build directory, your cache directory, and we'll need to check out the extended APIs repo and the Hypervisor repo. The reason we need the extended APIs is that there are additional APIs that are needed to be able to actually boot Linux or Windows once you have EFI up and running. Once you've set up those four different resources within your working directory, we'll need to actually copy out the config file from the hypervisor. Now, we're going to use the example config. This is also talked about in that video in the front page. And so now that we have the config, we're going to go into it and configure it. We need to turn on the extended APIs, which allows us to use the repo that we downloaded, and we will also need to turn on building using EFI. So this will actually cause the build system to generate an EFI executable. It should be noted that once you turn this on, other things can't be turned on. So for example, unit testing is disabled, most of developer mode is disabled, and static builds are required. There are two other variables that we have to set up. One of them is the override VMM, and the other one is the override VMM target. The override VMM tells the build system which VMM you want to use as your main target for EFI. So it actually tells you the resulting VMM that you want to use. The override VMM target specifies the target name that's used to build that VMM. What this does is it gives the build system the name of the dependency that EFI has. Unfortunately, there's no easy way for us to do this outside of this sort of variable set. So so to fill in those variables, we're actually going to have to get that information. So for the sake of this this video, what we're going to do is we're going to leverage one of our integration tests. To get an operating system to actually boot, you need unrestricted guest support. The reason for this is that the operating system is going to try to do an etcp, and it's going to step through the CR0 and CR4 process, where it's going to start flipping bits in there to move you from protected mode, that's 32-bit, all the way up to 64-bit long mode. So you need unrestricted guest support to make that work. To get unrestricted guest support to work, you need EPT. And the way our APIs work is that you have to provide your EPT map, because we really don't know what type of EPT mapping you want to use for whatever hypervisor you're trying to create. So our integration test for EFI really does nothing more than just sets up an identity map so that there's EPT there for unrestricted guest support. An identity map basically means that there's one-to-one mappings between physical and guest physical. So to find the integration test, we're going to go into the extended APIs within the VMM, then into integration, Arch Intel, and then from there EFI. And we can look at our CMake file, and this will show us the different things that are being created. So the second one is the test that we're going to use for this particular example. So now if we go back into our config, we now know the name of the VMM that we're going to use. And it just so happens that the name of the target that builds this VMM is very similar. It's just that. Okay. And you'll know the name of the target for your project because it's whatever the name of the target that you used to compile your extension. And then the VMM is whatever you add to that add VMM macro when you're creating your extension. And that's it. So now that we're in here, we can run CMake as we normally do. And we can go ahead and build. All right, so once this is done compiling, we'll come back and we'll take a look and see what the build system actually spit out. All right, now that the build is complete, let's take a look at our prefix folder to see where the EFI file is located, which actually you can kind of see it in the path above. So if you look at prefixes, then user space, x86, then EFI, then from there, bin, we can actually see that there's a bareflank.efi. This is the EFI file with the hypervisor built into it. So all you have to do is take this file, put it somewhere where it can be loaded from EFI. Now, for the sake of this example, we're going to boot into an EFI shell, and then we'll start up Bareflank, and we will then start up our host operating system. In a more production environment, you would put bareflank.efi onto the system somewhere and then configure your system to boot Bareflank before you boot your operating system, and then kind of chain load from there. It's really kind of up to you on whatever deployment scenario you want on, and what type of BIOS you're actually using for how those types of things are deployed. So this is really the main thing that you need, though, is the bareflank.efi. To actually do the install for this example, I'll show you my bash rc file. In here I have a install alias, and what this does is it takes the EFI that I just showed you and it puts it under EFI Ubuntu. It also takes that same file and puts it under Microsoft boot. That way we can test out both Ubuntu and Microsoft Windows. I'll keep in mind that you can really kind of put it anywhere. I just put it at these two spots because that way I can just cd into one of these directories, start Bareflank, immediately start the operating system, and not have to cd around. So it's just easier this way for me. So from here, I can actually run this command, and it's now installed on the system. So next step is to reboot. So we'll let this continue. Now for our system, I actually have to provide a USB stick that actually has shell.efi sitting on it. And not all systems work this way. So some of them require very specific file names. So for example, I know on like some of the Surface devices that Microsoft provides, you need to have a specific path, and I think the file name is boot x64.efi. And for other systems like Dell, you can actually tell it what sort of folder you want to boot to or what file you want to boot to. So you can actually add like a menu item to the boot process. So every system kind of has a different way of doing this. So you're going to have to kind of figure that out for whatever system you have. Once you're in the EFI shell, you can then move towards wherever you put bareflank.efi. We'll start with Ubuntu. And so if we look inside of this folder, you can see everything that is put there. I put a test folder just to see if I could read and write to the file system a while ago. Everything else is pretty much standard except for the inclusion of the bareflank.efi file. So we're going to go ahead and execute that. And the way you execute it is you just type its name, hit enter. Bareflank is now executing in EFI. So all the cores are now running Bareflank. From here, we can actually go and run Ubuntu and get that started. And so as you can see, Ubuntu is starting up as normal. It likes to turn the screen off on my hardware while it's booting. All right, so here we are. And now, once it's up and running, it's going to be kind of difficult to tell if it's actually working or not, because in this configuration, Bareflank really isn't doing much except for trapping on CPU IDs. So to actually test to see if it's there, we provide a make ACK, which will return back success if the hypervisor is actually there. So that's it for Ubuntu. let's go ahead and do the same test, but do it with Windows. So once again, we're going to have to, on my system, we have to boot into BIOS so I can launch the EFI shell from a USB device. And then from here, instead of going into Ubuntu, we will instead go into Microsoft. Oh, start Bareflank again. And then Microsoft's actual bootloader is this. I'm not really sure what that stands for. Boot manager something probably. But either way, run this. This will start up Windows. And as you can see, Windows is starting up, normal. And like I said, it's actually going through the full CPU boot process, including init-cp for all the cores. So there's quite a bit there that it's doing. And we had some Windows updates. Isn't that always the case? All right, so there we go. There's Windows running from us booting, Bareflank first from EFI. So that's pretty much the two major environments that we support. That's pretty much it for this video. If you like this video, please click the like button. If you have any questions or comments, please provide them in the comment section below. And if you have any more ideas for future videos or things that you would like us to clarify or explain or provide a tutorial on, also please provide those in the comments below. Thank you very much for watching. Bye.